All right, class, welcome back. We are doing pre-algebra, lesson 1.7, and we're finally talking about multiplication, my favorite. A very, very simple concept. The idea behind multiplication is that if you have the same addends or the same numbers that you're going to add in a series, well, you can save yourself some time and just multiply. Let's get started. So let's start with a simple problem first, right? If I have 3 and I'm adding to itself 3 times, listen to the word times, right? I would get 3 plus 3 added to 3, which is 3 plus 3 is 6. 6 plus 3 is 9. When you add 3 to itself 3 times, you will get 9. Watch this. 3 times 3 is 9. Another way to say this is 3, how many times? 3 times, which is 9. The numbers in blue are what we call factors. Those are the things you put into a multiplication problem, the numbers. And what comes out on the other side, the output, is the product. The answer to a multiplication problem is called a product. Just like in a factory, how you have the factors of production, the land, the materials that go in, they get squished and mangled together and you spit out a product. Factors go in, products come out. That's pretty much it. So let's try some visualization of what that looks like. So we just did 3 times, right? What this looks like is, let's say you had, I don't know, 3 apples, right? Yeah, sure, that's good. 3 apples. Here's 1 apple, here's 2 apples, here's 3 apples. This is 3 apples 1 time, right? This is a group of 3 apples 1 time. So 3 times 1 is 3, not 1, 3. Then we add another group of 3. 1, 2, 3. That is 2 groups of apples. How many apples are in each group? Well, 3. So 3 2 times is 6. And now finally you have 3 groups of 3 apples in each group. 3 apples in 3 groups would give you a total of 9 apples. 3 times is 9. Simple, right? Let's try another one. So let's say I had 2 groups of apples, and in each group there were 3 apples, right? So you should get 6, right? 2 times 3 is 6. If you wrote it out as an addition problem, you'd get 2 3 times. 2 plus 2 plus 2. That's 2 once, that's 2 twice, that's 2 3 times, right? You should have 1 apple, 2 apples, 3 apples, 4 apples, 5 apples, 6 apples. That is a group of 2 once, a group of 2 twice, a group of 2 3 times. 2 3 times is a product of 6 altogether, right? 2 times 3 is 6. In the same way, 3 2 times is also 6, right? You have a group of 3 plus a group of 3 plus a group, oh, I'm sorry, not 3 groups, but 2 groups of 3. So there's 1 group of 3 apples, and there's 2 groups of 3 apples. Count them all, what do you get? 1, 2, 3, 4, 5, 6. Simple, right? Multiplication is reversible like that. It doesn't really matter which number comes first, because basically the same thing is going on. Either you're going to have the groups first and then the individuals in the groups, or you're going to have the individuals in the group first and then the number of groups. Either way, you can always draw out a picture to figure out what's going on. Okay, but we're not here to do simple multiplication. We're here to do multi-digit. So let's talk about multi-digits. Multi-digit means multi, many, digits, numbers, many numbers. So we're going to start off with a large number. We're going to say multiply 82 times 7. Right now, what I'm going to do is show you the different ways you can write a multiplication problem. This is the first one called stacking. That's the common one you're used to. I mean, I call it stacking. I don't know what other people call it, but it works for me because it's a stack, right? It's one on top of another. The other way you could write it is 82 parentheses 7. And anytime you see a parentheses in algebra, that just means multiply. You could also do it, I'm just going to stop switching colors because it's taking too long, 82 times 7. You could also do 82.7. All of these mean the exact same thing, 82 7 times, right? So what's the actual math going on? Well, basically what you're doing is you're saying, all right, there are 82 people in each group. And there are how many groups? 7 groups. So it's 82 plus 82 plus 82 plus 82. So that's 4, that's 5, that's 6, and then that's 7. 82 added to itself 7 times. That's all it means, right? And then I'm not going to do all that math. So we're just going to do the multiplication side, right? So here's how it goes. So using stacking, you start with the ones, just like we did in addition, and you do 7 multiplied by 2. 7 twice is 14, right? 7 times 2 is 14. I'm going to use the darker color, is 14. I carry the 10 over to the 10 spot, so I carry the 1. Now I do 7 times 8, and 7 8 times is what, 56, I think, 49, and then, yeah, 50, 56. 9 and another 7. Yes. Okay. So 7 times 8, 56. 56 plus 1 is 57. See, even math teachers have to confirm. 574. That is your final answer. And this is your product. 82 7 times is 574. If you don't believe me, you can add up all those 82s together, and that will get you your 574. All right, simple enough. Let's try another one. Let's try 57 multiplied by 36. I've made the 1s blue, and I've made the 10s red. So basically what you're going to do when you have like say 2 digits on 2 digits, you do the exact same thing we started with. Start with your 1s, and you do 6 times 7 first. 6 times 7 is 42. 6 7 times is 42. I carry over the 40 to the 5 section, and I say, all right, what is 6 times 5 now? 6 times 5 is 6 5 times, which is 30. 30 plus, and then I add, right? And then I add this 4 on the top. And then 30 plus 4 is 34. So on this top section, I'm going to have 34, which is my final answer, and a 2, 342. I'm going to get rid of this 4 now because I'm not going to use it. And now I start to deal with the next number over, which is the 3. And then I do the exact same process. I go 3 times 7, right? 7 times 3 is 21. I drop the 1s place one side over, right? Because everything underneath the 6 belonged to the 6. Everything that we multiplied with the 3 belongs to the 3. Some people put a 0 here as a placeholder just to make sure that we don't use it. I don't do that. Feel free to do so. It's good practice. But anyway, 3 times 7 is 21. I bring the 1s place down, and I push the 2 over to the next sector because it's 10. It's technically 20, so it's 2 10s. And then I have 3 times 5, which is next. 3 times 5 is 15. And then that answer plus the 2. So 15 plus 2 is 17. So I just add the 1 and the 7 here for the 17. Then I add them together. And I go 2 plus 0 is 2. 4 plus 1 is 5. 7 plus 3 is 10, so I put the 0 here and move the 1 over. 1 plus 1 is 2. I should have 2,052. And that's how you do stacking. Now, I personally don't like stacking because it is sometimes confusing what to do first and then how this section right here with the adding is supposed to work. Some people don't like stacking. There's another way you can do this. It's called lattice multiplication, L-A-T-T-I-C-E. And what a lattice is when you go to a garden and you see like a, kind of like a wall and it has little, I don't even know what the words are. What they're lattices, you know, and the vines crawl through them. It's like one of those white panels and the vines go through them. Anyway, a lattice just means a grid, right? Fences are lattices. Some grills are lattices. Some shoes on the bottom have lattice grids, okay? So anyway, here's how lattice multiplication really works. It's popular in many Asian countries and in some European countries, actually. And here's how it works. So basically, you're going to write out your first products, your first factors, sorry. You're going to have the 5 on the top and the 7 over here. That's the 57. And then you're going to draw a line underneath them. Then you're going to draw a line down. You're going to make a box. You're going to have your 30 here, and then your ones place here, 36, okay? What you're going to do next is you're going to draw a box for each of the spots, right? You see that? So you have the 7 times the 3 will go in this box, 7 times 6 will go in this box, 5 times 3 will go in this box, 5 times 6 will go in that box. So you should have a box for each of your numbers. So say it like this. If you have 4 digits altogether, you should have 4 boxes, right? That's just simple. Okay, now, what I'm going to do is I'm going to draw lines, diagonal lines, from the bottom to the top of each of these boxes, okay? Some people like lattice multiplication because it's very artful, right? Sometimes it's cathartic. Anyway, back to work. So in this first box, what I'm going to do is I'm going to multiply the 7 times the 3. 7 times 3 is 21, right? So what I do is I take the 2 and I put it here, and the 1, I put it there, 21. Then I do 7 times 6. 7 times 6 is 42. So I put the 4 here and the 2 here. So far, so good? Then I do the 5s. 5 times 3 will fit into this box, which is 15. I put the 1 here and the 5 there. I'm going to slow down just a bit so people can catch up. And then finally, I do the 5 times 6. 5 times 6 will go in this box, the last remaining one. 5 times 6 is 30. So you put the 3 here and the 0 there. So now it looks a little like, you know, some type of Sudoku puzzle or some type of math puzzle, but it's really quite simple. What we're going to do next is you're going to start at the back or the bottom right here, and you're just going to add everything in a column. Let me show you what the columns are. If you'll excuse me, I'm going to erase these so there's less to look at. Ooh, come back. Okay, I'm going to erase these, all right, and redraw my line. So imagine everything I'm shading is a column, right? So this is a column, that's a column, that's a column, that's a column. All we're going to do is add straight down those columns, okay? So watch this. 2. 2 plus nothing in its column is just 2. So we write down the 2 here, right underneath it. I start up here and I go straight down. 1 plus 4 is 5. 5 plus 0 is just 5. I'm done with that column. The next one, I start up here and I go down. I say 2 plus 5. 5 plus 2 is 7. 7 plus 3 is 10. I have a 0 here for the 10, and then I just add that 1 to the top column here, and I continue doing it. 1 plus 1 is 2. And now I just start here and I drag it across. I have my numbers in order. That is 2052. 2052. So again, you can use either style. You can use the lattice, which we can call packing, because look at how contained and nice and neat it is. And then you have over here stacking. Again, feel free to use whichever one you want. I personally don't care. I prefer lattice multiplication because it looks prettier and it keeps things in order. But feel free to use stacking if you want. I'll do both in this video so that you get a good try either way. All right, let's try another number. Let's try a problem that has different digits in each number, right? So here's a good one. 538. 538, I'll use this color, times 17. Times 17. All right, if we're using stacking, here's how it's going to go. We start at the end. We go 7 times 8. 7 times 8 is 56. 5 will come up here because it's a 50. 7 times 3 is 15. 15 plus 5. Sorry, I'm sorry, that's not true. 7 times 3 is 21. 21 plus 5 is 26. So the 6 will come down. And the 2 will be shoved up here. Cross out that 5, we don't need it anymore. 7 times 5 is 35. 35 plus 2, we're always adding that extra. 35 plus 2 is 37. Okay, I'm going to erase these because we don't need them anymore. We no longer need them. And now I'm going to clean this up. And all right, let's do the ones now. Some people, again, like to add the 0 as a placeholder. Feel free to do that. Now I do 1 times 8, which is 8. Goes right below there. Then I do 1 times 3, which is 3. Let's get pushed over. And then I do 1 times 5, which is 5. Now I do my adding. There's always, the second step is always adding. 6 plus 0 is 6. 6 plus 8 is basically 6 plus 6 plus another 2 because 6 plus 2 is 8. But anyway, 6 plus 6 is 12. 12 plus another 2 is 14. So the 4 goes here. 7 plus 3 first is 10. 10 plus 1 is 11. 5 plus 3 is 8. 8 plus 1 is, this is the red one up here. 8 plus 1 is 9. So my answer is 9,146. I did not keep my colors consistent, sorry. Now, that's stacking. This is how you would do it if you did packing or lattice multiplication. Again, I write my first number on the top, 5, 3, 8. I draw my line across. And then I draw my number, my second factor on the side, my 1 and my 7. Notice now that this box is only going to be 3 by 2. The other one was a 2 by 2, right? Again, the number of digits you have is the number of boxes you should end up with. So I just draw straight down, straight down, straight down, right? So I have 1, 2, 3, 4, 5 digits, right? And each digit's pairing gets its own box. So right, this is going to be 5 times 7's box right here. This is going to be 5 times 1's box. This is going to be 3 times 1's box. This is going to be 3 times 7's box. You get the basic idea. It's a grid. Anyway, moving on. This will be our last one because the video is running a little long. But anyway, let's start at the beginning. You don't really have to start at the edges. Don't forget to draw your diagonal lines, the lattices. That's why it's called lattice multiplication. I like to make them as straight as possible because it's artful and it keeps everything in order. All right, now I'm free to do my math. All right, 8 times 1. this first box is going to be 8. Oh, that's a good thing. 8 times 1 is 8. There is no number to put in the 10 spot, so we just put a 0. So it's 0, 8. Now, 8 times 7 in this last box down here is 56. I have a 5 in the 10 spot, a 6 in the 1 spot. I move over to 3 times 1. 3 times 1 is just 3, so it's going to be a 0 in the 1 spot, in the 10 spot, sorry, and a 3 in the 1 spot. I'm going to finish this line out. 5 times 1 is 5, so I'm going to have a 0. Oh, I didn't draw my lattice here, sorry. I'm going to have a 0 in my 1 spot and a 5. A 0 in my 10 spot and a 5 in my 1 spot. Sorry, it's hard to think and write at the same time, guys. All right, now let's finish out this box. 3 times 7 is 21. So a 2 in my 10 spot and a 1 in my 1 spot. Finally, 5 times 7, which is in fact 35. I'm going to have a 3 in my 10 spot and a, what did I say, 35? And a 5 in my 1 spot. All right, so the multiplication is done. Look at how clean, look how Christmassy it is, right? Next, I do my addition. Remember, all I need to do is add along the diagonals. So 6 by itself is just a 6. A horse is a horse, of course, of course. Let's do 8 plus, I'm going to do this next column. I've got an 8 and a 1, which is a 9. A 9 and a 5 is a 14. So I'm going to put a 4 down here. And I'll push the 1 to the next column. So now I'm doing this next column. I'll circle the columns I'm doing as I'm doing them. I think that helps. So I've got a 1 and a 0, which is 1. 1 plus 3 is 4. 4 plus 2 is 6. 6 plus 5 is 11. So I put the 1 down here. And I carry the 10s up. Now I'm on this next column. Or this row, whatever you want to call it. I've got a 1 plus a 0, which is a 1. A 1 plus a 5, which is now a 6. A 6 plus a 3, which is now a 9. So 9 there. And then there's nothing in the last column because it's just a 0. 0 plus 0 is 0. I don't even need to write anything. I like to draw my little dot to tell me which way to go and the arrow. All I need to do is put the numbers down. 9, 1, 4, 6. Behold, we got the same thing. 9,146 is the product of 538 times 17. Let's do one more just to be safe, okay? I'm sorry we're going a little long today. We're going to do one more just to be safe. Let's do a simple one with 3 digits and multiplied by 1. So let's do 153 times, I'm going to use a different notation, times 6. Okay? If I'm using stacking, I'll do 1, 5, 3 times 6. 6 times 3 is 18. Carry the 1. 6 times 5 is what? 30. 30 plus 1 is 31. Carry the 3. 6 times 1 is 6. 6 plus 3 on the top is 9. Right? 918. That's it. Okay. There's nothing else to do. Let's use lattice multiplication now. 1, 5, 3. So far, so good. I'm only going to draw a 1 by 3 box because there's only one number I'm multiplying by. I'm now going to draw my little cells. Each one has a cell, good. And my lattices to divide them. Okay. Not clean. There we go. Now, 3 times 6 is, what, 18 we said? So a 1 here, an 8 there, there's your 18. 5 times 6 is 30, so I'm going to get a 3 in the 10 spot, and a 0 in the 1 spot. Then 1 times 6 is 6, so there is no 10s, so just a 0 and a 6. And now I do my adding. First I start with the 8. 8 plus nothing is just 8. 1 plus 0, next column, is just 1. Okay, next column, 6 and 3 is 9. Oh, look at that. And then 0 plus itself is nothing, so forget it. It's not worth even talking about. 918, 918. We did it. We did it. All right. So today, what did we learn? First, we learned that we learned in Mr. Thomas Teaches, multiplication is the same thing as repeated addition. It's the same thing as adding the same number to itself several times. 1 times 2 is the same as saying 2 plus itself, which is just 2. 2 times 3 is the same thing as saying 2 added to itself 3 times, or 3 added to itself twice. We learned that we can use stacking, which is when you put 2 numbers on top of each other, or you can use packing, also known as lattice multiplication, so called for the grids it creates. 173 times 91. Either way you go, as long as you know your multiplication facts or you're able to understand this concept here, you are good to go. All right, hopefully this helps. We will see you in the next video.